Hello, class. Welcome to another class, another time. I hope you've had a good time, good day, good morning, afternoon, or evening, wherever you are. We're in another topic, Module 2, our second class, and we're going to be talking about another interesting topic called unlocking the data, unlocking the power of data, cleaning and pre-processing, unlocking the power of data, cleaning and pre-processing. So before then, I would love to introduce myself once again. My name is James Olaniyan. I am a project manager, community liaison in the Laboratory of Data Science at Purdue University Fort Wayne. Um, and I'm going to be taking us again today. So let's start the class. Introduction, yeah. What exactly is data cleaning? We're going to be learning about cleaning data, preprocessing raw data for analysis and for making decision. All right. So today, um, let's talk about what we want to do. So what exactly is data cleaning? You know, what exactly is data cleaning? Data cleaning in simple terms is just, from the word data and cleaning, we already have an idea of what it means. So data cleaning has to do with is a process of detecting and correcting errors or inconsistencies in a data set. You know, it may involve identifying and fixing mistakes. It may involve removing duplicates. It may involve handling missing values. It may involve ensuring that data is consistent. Data is formatted consistently. You know, and essentially it's like giving a data a thorough scrub to ensure that it's accurate and reliable for analysis. That's just exactly what data cleaning is all about. So we're going to be talking about the importance of data cleaning. And one of the most important thing in data cleaning is that it ensures accuracy and reliability in analysis, like I mentioned earlier. Data, we want a data that is accurate. We don't want a data that is not completely accurate. We want a data that is reliable, not a data that when we come tomorrow or you access it any other time, it's going to be something different. We want to have the same thing we've seen today without any form of change. We still want to see that same value next time we come visit it. So we're going to be talking about like overview topics to cover handling missing data. We're going to be talking about outliers and data transformation. So let's go to the first thing for today, which is handling missing data. Now, so what are missing data? Missing data, I mean, in just clear terms, simply means that some information is not available for certain parts of our data set. So we have a set of data, but we found out that some part of it is missing. It's like having a blank space or gaps in your data table. So you have like a table, I mean, with names, subjects, columns, and boxes, but in some boxes we have some spaces there. There are no values in those things, in those boxes. That means that um, it has missing data. This can happen for many reasons, like someone forgetting to fill in a form or a sensor malfunction. There are several reasons why this thing could happen. And dealing with missing data is important because it can affect the accuracy of our analysis. Just like completing a puzzle, we need all the pieces to see the real picture, the complete picture. So imagine you have all the pieces, but there's just one missing. Once you can't find that missing one, it's not going to fit in. You can't get the complete um, picture of what we're trying to fit in. So that's exactly what um, missing data is all about. So how do we handle those missing data? Let's talk about it next thing. What are the methods to handle missing data? you know Deleting. You could remove rows or columns with missing values. You could also do what we call imputation, which means estimating missing values using statistical methods like mean, median, mode, which I already talked about if you remember our first module one. Machine learning algorithm, we'll get there. just using some level of algorithm to be able to, do imputation. And we have considerations which has to do with impact on data integrity and analysis outcome. Yeah. So now let's go to the next subtopic, which is outliers. What exactly is outlier? Are they friends or they are foes? What exactly are outliers now? Outliers are data points that significantly deviate from the rest of the data set. They are observations that lie outside the typical range of values and patterns exhibited by the majority of data. They're just something that can occur due to various reasons. They could occur due to measurement errors, data entry mistakes, or genuine or rare events. Identifying outliers is essential in data analysis, and they can have a significant impact on statistical analysis and machine learning models. How do we detect outliers? There are two methods that I know we can use to detect. We have using statistical method called Z-score. And what's Z-score all about? Z-score it's just like a detective tool for data. We use it to spot outliers. We use it to compare data and for quality check. And how is it being calculated? It's just about subtracting. There's a level of algorithm involved in subtracting the mean, the average mean of a data set from the data itself, subtracting the mean, then dividing by standard deviation, and also interpreting it. So we need to know if it has a zero score. So if zero score of 0 means, if the z-score of 0 means the data point is at the average. If the z-score is 0, that means if it's positive, that means it's above average. If it's negative, that means it's below average. And that's exactly what it means. And visualization just has to do with you observing how your data is turning out. Like, is it being the boxes, like just like I mentioned about tables, seeing the empty boxes and making sure you're filling them up. Straight, we'll go to strategies for handling outliers. We can use eliminating outliers from the data set, just clearing out some things and badging it up, and transforming, which means applying transformations like logarithmic to reduce the impact of outliers. Now, what I think we need to consider, importance of careful consideration. Outliers may represent genuine data points or errors. Sometimes outliers doesn't necessarily mean they are wrong or they are fake. It's just like a pointer. It points us to something, whether the good or the bad. Now, the last one, data transformation. What are the purpose of data transformation? Making data suitable for analysis. Just very simple term. And in data transformation, we have normalization, standardization, log transformation. Normalization has to do with scaling data to a range from 0 to 1. Standardization has to do with scaling data to have a mean of 0 and a standard deviation of 1. Log transformation has to do with skewed data distribution. Now, what are our takeaways from data cleaning? Data cleaning ensures accuracy and reliability in analysis. It also helps us handle missing data, and data transformation are essential for pre-processing steps. Importance of careful consideration. Pre-processing data helps or impact data analysis in big term. I hope you've learned one or two things from today's class. Let's go straight to what I have for you today. What is your activity? You're going to be the data detective. All you need to do is form a small group, as we've always done. Each group will give a data set with a missing value, outliers, or untransformed data. Using this technique, learn, clean, and pre-process the data. Analyze those clean data, apply knowledge gained in that class, and use it in the real world. I hope you've learned one or two things from today's class. Let's not forget also that this work was supported by the Laboratory of Data Science and the Indiana Data Mine Grant, and supervised by Professor Alessandro Maria Selvitella at Purdue University for me. I hope you had a good time. Thank you, everyone. If you have any question, feel free to ask or send a mail to Laboratory of Data Science, Purdue University. Keep exploring the world of data science and its endless possibilities. See you next class. Bye.
Bye.